Okay, I'm live. Come in the room, come in the room, come in the room. Okay? Because today we're going to be talking about trigonometry. And for some people, they might need a little extra practice, but that's what we're going to do today. We're going to do a little extra practice. So get ready because I'm going to share my screen with you so you can see actual exercises. Here we go. And I'm hoping it's not too I had some issues earlier. So I'm going to close some things out. I'm not going to close you out, but I'm going to close some other windows out so that we're not having any issues with latency, because this is take 2 of the trigonometry warm-up, the special right triangles and radians video. Okay, so the instructions read: answer the following questions without using a calculator unless instructed otherwise. Well, I'm not instructing you otherwise. We're going to do this without a calculator because we want it to be in our mental process, right? How we do the right triangle exercises. And so, that being said, I'm going to draw out the right triangle for which we're talking about. And then there's really only 2 special right triangles that we're going to talk about. So, out of those 2, we're going to keep them in the back of our mind. We're going to keep the side lengths in the back of our mind and commit those to memory so that we can answer the questions properly. Okay? With that being said, let's go ahead and start out with number 1, the 45 degree 90-degree triangle. Okay, so I'm going to just draw it out for you, the unit triangle, and then from yeah, we're going to do the unit triangle, and then after that you will see how to answer the. So let me get my drawing tool. I'm going to say we have one leg and we have another leg, and let's just pretend, I know it's not drawn to scale, let's just pretend that that's 90 degrees, and that means this is 45 and the other one is also 45 because they have to add up to 180. Okay, so when we have a triangle, they have to add up, all to add up to 180 degrees. All right, so then this, on a unit triangle, should I call it? I shouldn't call it a unit triangle. But based on the unit circle, one that has a 45, we know that the side length is 1. The ratio is 1 to 1, right? And the hypotenuse is square root of 2. Okay. And we can also say that this is the radius of the this is the radius of the triangle. If it was on a unit circle, or no, I'm sorry, not if it was on a unit circle. If it was on a 2-dimensional plane. Okay. Anyway, I digress. That's a special triangle that we need to know the sides of. And then there's another one that's well, we'll cross that bridge when we get to it. The other one is a 30-30-60. I mean, 30-60-90. Woo! Goodness. Let me get my explanation straight. Okay. So 45-45-90 has legs. So this new triangle that they're describing has lengths of 8. So the legs are length 8. Okay, so let's draw another triangle. Let me make it a different color. Okay. Let me make it green. All right. So let's say we have another right triangle. It has the same angles, 45, 45, 90, right? But it says the legs are 8. So what does that mean for us? That means it's 8 times as big as this unit one, as this basic one. And since we would call it a similar triangle because they have the same angles, but the legs are a little bigger. So they're this is like a big exploded, big size triangle. It's not really the same size, even though they look about the same size on my drawing, but in actuality, just for the sheer number's sake, we know that it's 8 times, right? Because 1 times 8 is 8, 1 times 8 is 8. So then we need to multiply this in order to find this hypotenuse, right? Because it says find the hypotenuse. In order to find the hypotenuse, we need to multiply this by 8. Okay, so the hypotenuse equals 8 times square root of 2. Okay, so that's the first answer. Let's go on to number 2. Still see this since it's also 45, 45. I'm trying to erase this. Okay. All right. So we're going to use this as a reference. We have another 45, 45, 90 triangle, which has a hypotenuse of 10. Okay. It has a hypotenuse of 10. Find each leg. And we already see the relationship between the legs. We know it's 1, 1 square root of 2, right? 1, 1 square root of 2. All right. So let me write this out. 1, 1 square root of 2. That's the ratio. That's a relationship that we have. But now this one in particular says that even though it's 45, 45, 90, the hypotenuse up here is 10. Okay. Okay, so if that's true, then what we have here is 1, 1 square root of 2. So now we have x, y, 10. Okay. So basically we can set up a proportion, right? Because they're proportional to each other. Okay. So 10 is to square root of 2 as y is to 1. Okay, well, we don't have to write the 1, but we know that that's it. So now we can tell what y is. And guess what? Once we find y, it's the same because it's also 1. It's the same with x. Okay? So that's how we're going to know the actual value of the length of each leg is. So if we solve for y, which is just y equals 10 over square root of 2, we're going to basically rationalize this 10 over square root of 2. Okay. We get that rationalizing mean we're going to multiply top and bottom by square root of 2. Okay. So this is multiplication. And so when we square the bottom, that's just going to give us 2. Square root of 2 times square root of 2 is just 2. And then at the top, we'll have 10 square root of 2. Okay. Now that we have 10 square root of 2, You can see 10 divided by 5 is easy to figure out. It's just half of 10, which is 5. So this is 5 square root of 2. Okay. So that's y. And guess what? It's also x. Okay. So we're going to just kind of put that as also x. Why is it also x? Because we're also going to get that same ratio happening, right? 10 is to square root of 2 as x is to 1. It's going to just have an x here instead of y. And so we'll find out that is also x. Okay. If you have any questions, feel free to drop a comment. Put a note in the chat if you want to see the reason why x and y are the same. Okay. All right. So let me go on over to back to my trigonometry warm up and say this we're going to call y, and we're going to say it's equal to 5 square root of 2. And then this down here is also 5 square root of 2. Okay. All right. And that's x. Okay. On number 3, we have 30, 60, 90 triangle. Okay, so that's a little bit different. Let's just say that we have 30 degrees here and 90 degrees here and 60 degrees up there. Now, whenever 60, the shorter side or the smaller angle is going to have 1 as a side length. Then opposite to that is a 60 degree, and that's going to be 3. And the hypotenuse is 2. Okay, this is a special triangle. When we know this, we can kind of get the values of the other one. We call this the short leg because it's across from, it's opposite to the smaller angle. Okay, so in our question, it says the triangle has a short leg and okay, so 30 degrees is the short leg. And it says it's 7. Well, that's 7 times the 1, right? 7 is 7 times that one side. So that means everything else is times 7. Okay, so it would be 7 times 2. And then 7 times square root of 3. Okay. Okay, so that means it says find the long leg and the hypotenuse, and we just did. So the long leg, we'll call it the adjacent side, A. Okay. Oh, well, we could say X. Let me just say X. I'm going to use X's and Y's. Okay, we'll say this is Y and this is X. Keep it consistent. But the only reason why I said A is because of SOHCAHTOA. And I'm going to show you that in just a second. Because I want you also to recognize trigonometry from the trig functions. perspective. Okay. Right now we're just doing the relationship with the triangle, but I haven't really talked about the sines and cosines. But if you could see, problem number 5 is start talking about sines and cosines. So we're getting ready to do that. Give me 1 second. So let's finish up by saying y is equal to 7 and x is equal to 7 square root of 3. So all it did was multiply by 7. Okay. So, oh, I mean, it didn't, the hypotenuse, actually, we already know why it's 7. You got hypotenuse, which is 7 times 2. So H, we can also call it R, right? R for radius. So let me take that back. For this one, I'm just going to call it R. R for radius equals 14. Also known as the hypotenuse. Let's just point to hypotenuse. About that. Instead of me writing out hypotenuse, I'm just going to send the arrow that way. All right. How are we doing? All right. Everybody good? Good, good, good. All right. So next, we're going to do 30, 60, 90 triangle. Okay. So this triangle is also a right triangle because one of the angles is 90 degrees. All right. But this is 30. And up here is 60. It kind of looks opposite, but it's not drawn to scale. And I apologize in advance. I'm not the best artist. But across from 30, hold on. Oh, I did do a 30, 60. Use this as a reference since we already have it. We'll use this from number 3. So triangle, and it has a hypotenuse of 18. So let me get another color. I'm gonna get purple. All right, so this time our new triangle, all right, is also 30, 60, 90, but it has a side length of 18. Hypotenuse side. Degrees, and the hypotenuse is the long side. Opposite to the 90 is the hypotenuse. And so, and we can also call this the radius. And so we'll call it, we'll say that this length is 18. Just that's what it says. Okay. That's 18. And we want to find y and x. Okay. I'll just go based on the logic that I had kind of set up from before. This is 18 and our normal one is 2. 18 is a multiple of 2. Which multiple of 2 is it? Well, it's the 9th multiple of 2. 9 times 2 is 18. So since it's the 9th multiple of 2, this triangle is the 9th multiple, okay, of this unit triangle. This triangle is the 9th multiple of this triangle. Because if 1 is a multiple of 9, right? 9 times 2. That means this side is 9 times 1. And then this side is 9 times square root of 3. Okay? So we can just use that scalar multiple pattern to figure out what the both leg sides are. Okay, so we just found them out. Okay, now next we want to evaluate sine of 30 degrees. Now, I could kind of use this, but I also want to just set up the stage for you using SOHCAHTOA. Okay, so there's a relationship called SOHCAHTOA. That's what I learned back in the day. It's a mnemonic device that helps us to remember the relationship between the sides of the special triangle. Okay, so the sine opposite O is for opposite, H is by hypotenuse. Okay, this time we're going to do 30 degrees. And we've already done a 30, 60, right? So you kind of know what this is. This side is 1, this side is square root of 3, and this side is 2, right? So H equals 2. O equals 1. And A equals square root of 3. Okay, knowing this, we can do the sine. The sine is opposite over hypotenuse. So O over H. Okay, so the sine of 30 equals O over H, which equals to 1 over 2. Okay? You know, once we get to practicing, it'll be a little bit faster, but as I'm explaining, it go a little slower. But you get the drift. Okay, so now we're going to evaluate cosine. The S stands for sine, the C stands for cosine, and T stands for tangent. So notice we're doing sine, cosine, tangent. So we're going to do that, and then we're going to do a sine and a cosine, and then we're going to multiply. Okay. Cosine of 60, we know that this side is 60. Let me go ahead and switch colors for you. This is 60. Okay, so cosine of 60, adjacent over hypotenuse, the adjacent side is 1. That's adjacent to the 60. That means adjacent means right next to, right? So the side that's next to it, that's not the hypotenuse, right, is 1. The length is 1. So we can say that cosine of 60 equals adjacent over hypotenuse, which equals to 1 over 2. Notice it's the same as the sine of 30. Okay. All right. Next, we're going to do the tangent of 45. So we need the 45, 45 triangle. Okay. Let's say this is 90. This is 1. This is 1. And this long side or hypotenuse is square root of 2. All right. So we need the tangent. Let's say this is 45. Yikes. That was a very long curve. Okay, so we say this is 45. This is our special triangle, 45, 45, 90. And so we use the sides. Opposite is 1. So we say tangent of 45 equals opposite over adjacent, which is equal to 1 over 1, which is equal to just 1. Okay? All right. Are there any questions so far? So far, so good. We have evaluated the 30-60 triangles, and now we're doing the 45-45 triangles. Let's go ahead and do number 8 and evaluate the sine of 60 times the cosine of 30. Okay? All right, let's do it. Okay, so sine of 60. Let's pull up our 30, 60, 90 triangle since we need that for sure. We can draw it real quick. This is 30. That means the side is 1. Then this side is square root of 3. And this side is 2. Okay. So it's very, very, very important to remember these two special triangles and their side lengths, right? So we can figure out the sine of 60. Sine of 60, let me see. Is sine is adjacent, SOHCAHTOA, right? Do you remember SOHCAHTOA? That helps you remember the relationship. So sine is opposite of our hypotenuse. All right, opposite over hypotenuse, which is equal to 1 is the opposite side. And hypotenuse, I'm sorry, 60. Lord have mercy. We need 60. I'm glad I caught that. All right, sine of 60, the opposite of 60 is square root of 3. Let's just turn that into a radical sign over 2. Okay, hypotenuse is 2. All right, so that's the answer. Oh, 9 of 60. Then we have cosine. So the cosine of 30 is going to be adjacent over hypotenuse. Adjacent of 30 is square root of 3. See, this is the adjacent side of 30. And the hypotenuse is 2. So this is also square root of 3 over 2. And so that is that. But that's not the answer. It says evaluate sine of 60 times cosine of 30. So that being the case, we have square root of 3 over 2 times square root of 3 over 2. That's equal to 3 over 4. Okay, because square root of 3 times square root of 3 is 3. And 2 times 2 is 4. All right, very good. Now let's go on to question 9. So A right triangle is 60-degree angle, has a 60-degree angle and a hypotenuse of length. So since it's 60, we can use our 30, 60, 90 triangle so they can figure out what is the side opposite to 60. That will be the 30-degree, right? Find the side. I'm sorry. Find the side opposite. Okay, so we got to read our directions really well. But the other angle is 30, right? So we're going to use a 30, 60, 90 triangle. That's going to help us. So let me draw that. The 30, and this is 60. And so opposite to the 30 is 1, opposite to the 60 is square root of 3, and the hypotenuse is 2. Okay? So we have the right triangle, and it says that the new one, or this is just the unit one, right? The one we know. But there's a new one that has the same angles, right? As a 30 as this one. So it's similar. Okay? And because it's similar, we can use the information that we have about it. So we're just going to make a new one. That's also a right triangle. It also has 30. It also has 60. Okay. And this is 60. And then this hypotenuse was not 2, right? Because it said the hypotenuse is 20. Oh, wow. Well, what multiple of 20 is 2? 10, right? Because 20 is 2 times 10. Since 20 is 2 times 10, and both of these are a multiple of 10. You get that? So let's look at this, and let's go kind of work our way backwards. So this is 2 times 10. On our original or our unit triangle, we'll say that it's 2 times 10 is 20. So everything has to be the same factor. It has to be the same scale factor. Okay. So since it's 2 times 10, everything is times 10. So we're going to do 10 times 1, which is 10. And then we're going to 10 times square root of 3. Now, I did it logically, right? And if we want, we can do it mathematically. We can say 10. If we wanted, we could say 10 divided by 2. I'm sorry, 20. Side length is 20. So I'm giving you the answer before I actually do it. 20 divided by 2 is 10. That's how we found this one, right? And we know that this is the same multiple, but by square root of 3. Okay? All right, so the side opposite to the 60. So 60 is over here. So the side that's opposite to 60, we'll call this x, equals 10 square root of 3. Okay, so that's what the question is asking. So if I had put 10, I would have been wrong. Or if I put I definitely want to put 20 because they give us and they tell us that it's hypotenuse, right? So it's definitely the one opposite to the 60 is 10 square root of 3. Okay. All right, let's move on to, unless there are any questions. Okay. All right. I saw someone watching. So I was just checking back to see if you have any questions. And I'll just say that in the chat too. Okay, so if you have any questions, feel free to ask. Okay? All right. Next, we have a ladder that leans against the wall, forming a 45-degree angle with the ground. All right, so we can say that our ladder is leaning, so it's on an angle. It's on an incline. Let's say that's let me fix that. Okay, so let's say that's our triangle. Okay, let's say that's our ladder. You like my ladder, y'all? That's my ladder. And it's leaning up against the wall. Okay. And we want to find out if the ladder is 12 feet long, how high up the wall? What's this height right here? Okay. So what is y? All right. So we don't know x, so we can't do Pythagorean. That's not really going to help us. So we're going to have to use our information about the 45-degree triangle. Okay. So we know that if this angle is 45 and this is 90, you know, that one is also 45. The side lengths, the legs are 1, and the hypotenuse is square root of 2. Okay? Have to commit that to memory. Have to know that. But once we know that and we see that, then we'll go ahead and use this to interpret what this is. Okay? So this is let's look at the ratio. The ratio of this unit is 1 to 1 to square root of 2. Okay? And then we want this triangle, which is x to y to 12. Okay? So we don't know x and y, but it's very similar to this 1 to 1 to square root of 2, right? So let's do a comparison. We'll do a proportion because they're proportional to each other because they have the same angles. All right, this is also 45. Since they have the same angles, that means they're like scalar multiples of each other. They're similar. So we're going to say 12 is to square root of 2 as y is to 1. We know this relationship. So that's y over 1 is just y, right? So we could say that y equal to 12 over square root of 2. But we don't want to leave that radical in the denominator to rationalize. Okay. Rationalize, we get 12 square root of 2 over 2. Okay, and 12 over 2. 12 divided by 2 is 6. That's square root of 2 right next to it. And that is y. So that's what we want to find. We don't even need to worry about x, even though it's the same, right? So, but the answer is 6 square root of 2. That is y. Okay. All right. Next. Oh, Now we're talking about pies. Not the pies you eat, but the pies that are on a circle whose complete circle is 360. Okay, this unit circle, and any circle for that matter, is 360 by the time you go all the way around. Um, and it's also 2 times pi, radians. And since we're doing everything in radians here, go ahead and convert to pies. Okay, if 360 is times pi, that okay, a full revolution is 360 or 2 times pi. That means pi is half of that, right? Pi is over here, and here's pi over 2, and here is 3 pi over 2. Okay, so we cut it out. We cut it up and get the different variations of pi here. So this is pi, that's half of 360. Half of 360 is 180. So this 180. Okay? Now we have 180. And so this is going to help us figure out what this pi over 4 business is, because so far we've been dealing in degrees, right? But now we want to do these pi radians. So pi over 4 is actually 180 divided by 4, which is actually 45. Now remember I said I want you to use a calculator. So I mean, if we had to look at it, since I just gave it to you, you can look at it half of, well, there's a common factor, right? This is even, so it's 90 divided by 2, and half of 90 is 45. So that's how we get 45. Okay? So we can break it down that way. So I don't want you to say, oh, like, how did you get it without doing any calculator? I know because I've done it many times, but for you, just to see the process, probably helpful, right? So 180 over 4 is 45. Great. We want to know what the cosine of that is. So we're going to pull out our 45, 45, 90 triangle. I mean, we can also say pi over 4, right? We can also say pi over 4, pi over 4, pi over 2. Okay, so keep that in mind. It's the same unit triangle. We want to know cosine. Cosine is adjacent over hypotenuse. Okay. Okay, so cosine adjacent over hypotenuse. So that is cosine of 45 is adjacent is 1. Hypotenuse is square root of 2. Okay. So cosine, but we don't want to leave that square root of 2. So we're going to rationalize. And we end up with square root of 2 over 2. Because square root of 2 times square root of 2 is 2. Okay. All right. Now we want to evaluate tangent of pi over 3. So we're going to use our, let me get a different color. We're going to use our 3060. Okay. 3060, that's 1 square root of 3 and 2. Those are the lengths, side lengths. And so then we're going to do this tangent here. So tangent is opposite over adjacent. Tangent, opposite over adjacent. Okay. Opposite to 30 is 1. Adjacent is square root of 3. Hold on. Oh, I'm telling a story. This is 60. And you know how I messed up? Pi over 3 is 180 divided by 3, which is actually 60 degrees, not 30. So we can still use a 30, 60, 90 triangle, but opposite of 60 is square root of 3. And then adjacent is 1. So it's equal to square root of 3. Okay? Okay. Next, we have sine of pi over 3 times cosine of pi over 6. All right, sine of pi over 3, which is 60. Okay, so this is 60 degrees, and this is 30 degrees. How do I know? Just take 180 divided by 3, you get 60. 180 divided by 6, you get 30. And we'll say sine of 60. Sine is adjacent. Let me just write it down because I don't want to just say it. Sine is adjacent over hypotenuse. Cosine, that's that SOHCAHTOA. I'm sorry. See, I'm glad I said it because I wrote it wrong. This actually opposite. Opposite over hypotenuse. And cosine is adjacent over hypotenuse. Okay, SOHCAHTOA. Okay, so that being said, opposite of a hypotenuse of 60, opposite is square root of 3. Hypotenuse is 2. And that's for the sine of 60. And then cosine of 30 is adjacent side of 30 is square root of 3 over the hypotenuse of 2. So we want to multiply those two. See, it says multiply. So that's going to give 3 over 4. Square root of 3 times square root of 3 is 3. And 2 times 2 is 4. All right. Last but not least, we have a unit circle. So I want you to imagine this unit circle, right? 1, -1, 1, -1, something like that. Okay. And the angle, let's say it's 45 degrees. It wants to know what is the x, y. So what is this y? What is this x? Value. Find the coordinates of the point. So it's going to be a little less than 1 as a x and a little less than 1 as a y. Okay, so let's figure out this x and y value. How are we going to figure that out? Well, we're going to use this relationship with the radius since we know this hypotenuse r is the radius. So if the radius is 1 and we know that's pi over 4, then we can use the 45 right? We could use the 45, 45, 90 triangle. We know that this is square root of 2 is 1 and this is 1. Well, on a unit circle, this r is 1. Okay? R is 1. Okay. And so the ratio, let's compare these ratios between this triangle and that triangle. The ratio here or the relationship is 1 to 1 to square root of 2. The ratio for this one over here is going to be um x to y to 1. Look at that. Okay? It's 1 here. This side length right here is 1. This r, the radius on a unit circle is 1. Okay? So the unit circle, the radius is 1. So this hypotenuse is 1. This is the hypotenuse. So we're matching them up so we can figure out what the ratio is. Okay? 1 is to square root of 2, right? 1 is the square root of 2 as y is to 1. As y is to 1. We want to find out what y is. That's the ratio. Okay, 1 is to square root of 2 as x is to 1. Okay, so they match up and these are both the same. So y is equal to square root of 2 over 2. I'm not going to rationalize because you've already seen me rationalize. If you multiply top and bottom by square root of 2, you're going to get square root of 2 over 2. Okay, so those are the coordinates of this this point right here. This point on the unit circle. All these points along this unit circle have a radius of 1. But we're just looking at this one in particular at 45 degrees. Okay? What are your questions? Do you have any questions? I'm here for it. Every time I look over, it says there's somebody signed in. So I'm going to wait and see if you have any questions. I'll review what we've gone over so far. So that you can ask whatever questions that you may have. Okay? So, let me just scroll to what we have and then I'll come right back. I want to scroll up and review. Let me review number 1. Okay. I'm going to be able to do 1, 2, and 3 here while we're both looking at it. Okay. So let me see. Number 1, a 45, 45, 90 triangle has legs of length 8. Find the hypotenuse. Okay. Hypotenuse is the long side that's opposite to the 90 degrees, to that little square in the corner. Okay, so opposite to the square in the corner is the hypotenuse. Okay, so the side of the triangle that's opposite to the little square is our hypotenuse. And on our special triangle that we know the sides of, our reference triangle, we notice that the side length, our side length of the question is 8 times that of 1. So we're going to just multiply each part by 8. So if each part is multiplied by 8, then we can see that the hypotenuse is 8 times square root of 2. Okay? 8 times square root of 2. Great. Now let's go to number 2. Number 2, we look at the 45, 45, 90 triangle, and it has a hypotenuse of 10. Okay, so if that triangle has a hypotenuse of 10, we want to find the length of each leg. Okay, in order to find the length of each leg, we're going to have to divide by our ratio. We're going to have to say 10 is to square root of 2 as y is to 1. Okay, so that is the ratio you see here, and it's equal to 10 divided by square root of 2. We're going to multiply by square root of 2 over square root of 2. That's like multiplying by 1, really. But we do that so that we can get the square root of 2 in the numerator and not in the denominator, and get rid of it out of the denominator. So we're left with 5 square root of 2. Okay. Then number 3 talks about the 30, 60, 90 triangle. So I drew over on the left the reference triangle with 30, 60, 90 degrees. The short leg is actually 7 in our example, and we want to find out what's the length of the long leg and the hypotenuse. So as you can see, 7, if we multiply 7 times 2, that tells us we have to multiply 7 times 1 and 7 times square root of 3 to get 7 square root of 3 for x and 14 for r, or hypotenuse, or h. Sorry. All right. Okay. Let me scroll on over, or scroll on down to number 4, 5, and 6. Okay. So number 4, 30, 60, 90 has a hypotenuse of 18. This is 9 times 2. On our reference triangle, if our reference triangle says 2, 18 is 9 times that. Right? So we're going to have to multiply everything by 9. 9 times 1 for the short leg, and 9 times square root of 3 for the long leg. Okay? It said find both legs. So we found out that y is 9 and x is 9 square root of 3. Oh my goodness. I wrote square root of 2, but I meant square root of 3. Please forgive me. I just noticed that. So good that we reviewed it, right? Because it's actually 9 square root of 3. Let me fix that real quick. I'm going to fix it and make it square root of 3. All right. Because it's 30, 60, 90. Okay. Now, let's continue on to number 5. Number 5 says evaluate sine of 30 degrees. 30 degrees is the short leg. I mean, this is the angle for the short leg. So the short leg is 1, and the long leg is square root of 3. Okay, so I kind of wrote those down out for you. Hypotenuse 2, opposite is 1, and adjacent is square root of 3. Because the SOHCAHTOA is the thing you have to remember. It's a mnemonic. You don't have to remember, but it helps. To me, it helps. I mean, it helped me when I was coming up and I was learning trig functions. So the sine of the angle is the opposite of a hypotenuse side. The cosine is adjacent over the hypotenuse, and the tangent is opposite over adjacent. Okay, so if we want to know the sine of 30, then we have to look at the opposite side to 30 and the hypotenuse of the reference triangle, which is 1 over 2 or 1/2. Then next, number 6, we evaluate 60, cosine of 60, which is adjacent of our hypotenuse, which is also equal to 1 over 2. Okay, the adjacent side of 60 is 1. The hypotenuse is 2. So the hypotenuse of 30 and 60 is 2, right? It's just that they're opposites when it comes to their adjacent and opposite side. Okay. Let's go on to question number 7. Let's scroll down. We can do 7 and 8. Okay. All right. Number 7 says evaluate tangent of 45. So we got our special triangle drawn here, and tangent is opposite over adjacent, which is 1 over 1 or just 1. Then we're asked to evaluate sine of 60, which is opposite over hypotenuse or square root of 3 over 2. And then the cosine of 30, which is adjacent over hypotenuse, is square root of 3 over 2 as well. When you multiply those together, you get 3 over 4. Okay? So far, so good. We're going to continue and review number 9 and 10. So let's do that. Number 9 says a right triangle has a 60-degree angle and a hypotenuse of length 20. So we want to find the side opposite the 60. Okay, so we're looking at a 30, 60, 90. And the 30, 60, 90 basically has an opposite. The opposite is on a reference. On the reference is square root of 3. But since the length is 20, we have some multiple of 2, right? 2 times 10 is going to give us a 20. So it's really a multiple of 10 going on here. So we know the opposite of 6 is going to be that 10 square root of 3. That's how we get x equals 10 square root of 3. Then we have a ladder that leans against a wall, forming a 45-degree angle with the ground. If the ladder is 12 feet long, how high up the wall does it reach? So we were asking for y here. And we have similar triangles, similar to the 45, 45, 90 triangle, which I drew to the left. Since they're about the same, they're only off by some multiple. They're proportional. We're going to look at the proportions. 1 to 1 to square root of 2, x to y to 12. We know that the ladder is 12 feet long. We're going to try to figure it out using proportions. So 12 is the square root of 2 as y is to 1. Okay, so we can say that y is 12 over square root of 2, but we need to rationalize because we just don't like that radical in the denominator. That's just the mathematician thing from as far back as we can remember. So it ends up being 6 square root of 2. Okay. Now, number 11. Number 11 says, what is the sine? What's the sine of pi over 6? Well, 180 divided by 6. Oopsies. It's supposed to be a 6 is 30 degrees. Okay, maybe I didn't do it. Okay, so sine is opposite sine of 30 opposite over hypotenuse, which is opposite of 30 is 1, hypotenuse is 2. Okay, so I don't know. I skipped over that number 11, but there you go. The opposite is 1, hypotenuse is 2. Um, and the more and more you practice, the more you're going to remember which one is opposite and which was hypotenuse and which one is adjacent. So just start thinking about that relationship and keep the SOHCAHTOA in mind. Okay. Then next we evaluate the cosine of pi over 4. Well, pi over 4 is 45 degrees. So we use the 45, 45, 90 right triangle. And cosine is adjacent over hypotenuse, which is 1 over square root of 2. And after you rationalize, it's square root of 2 over 2. So let me go ahead and mark that as our answer here for the cosine of pi over 4. Some people end up memorizing these answers because they're so common, but as long as you know your right triangle reference triangles, you don't have to memorize them per se. You can always prove them over again, right? You can always keep on proving them. You can always just start by drawing your triangle, writing the side lengths, and figuring out what the sine, cosine, or tangent. And then in another video, not this one, we'll talk about the opposites, which is the secant, cosecant, and cotangent. Okay. So that was 11 and 12. And now let's look at 13. 13 wants to know what is the tangent of pi over 3. 180 divided by 3 is 60. So we need to know what is the opposite over adjacent of 60. So the opposite to 60 is square root of 3. The adjacent is 1. So it's square root of 3 over 1, which is square root of 3. All right. So 14 and 15, let's look at it. Let's look at 14 and 16. 15, the last two. Okay, so we want to evaluate sine of pi over 3 times 6. We know pi over 3 is cosine of 30. Well, pi over 6 is 30 degrees. So sine is opposite of this, which is going to be square root of 3. And yeah, over 2. And then the cosine adjacent of our hypotenuse is square root of 3 over 2. So that we end up with 3 over 4. Number 15 says that on a unit circle, we want to know what the coordinates of the point that's at 45 degrees, right? Because 180 divided by 4 is 45. Okay, so we look at the ratio for our reference angle, and unit circle is x to y to y. Remember that on a unit circle, the radius is 1. Okay, and since the radius is 1, we can look at the proportions. We need both coordinates, right? X and y. So we're going to do 1 is to square root of 2 as y is to 1. Okay, so when we look at that, we can rationalize the 1 over square root of 2 and get same for x. X is 1 over square root of 2. So after we rationalize, it's square root of 2 over 2. So that's a wrap. That's it. Our warm up. I know this was a long explanation. I went ahead and reviewed everything. But if you would, please like, subscribe, and stay tuned for our next warm up video. It might be a trig video, it might be a algebra warm up. So if you're interested, go ahead and give it a thumbs up. And if you want me to do more videos like this, also give it a thumbs up and put in a comment if you have any desire to do different kinds of warm-ups, exercises. I'll be happy to go over them with you. I want to thank you so much for even getting to this point. If you'd like to set up a tutoring session with me, you feel free to go into the bio, in my bio, and set up your appointment on Wyzant. Or we can set up a Zoom session if you want to do that. If you don't want to sign up for Wyzant, feel free to reach out to me and tell me you want tutoring, and I will set up a Zoom session for you. And then you'll just click on that Zoom. You just tell me when's a good time. I mean, we can even schedule it right here in the chat, or we can schedule it in the comments. Either way, and then you can just click on the Zoom link and then we can go from there. All right. I want to see you be successful in math. I've already been there, done that, got 10,000 shirts. I do have shirts actually. I have Tutor House shirts, and if you like one, let me know. All right. Thank you so much for tuning in, and I'll see you next time.